Hello everybody, welcome back to the Tutoring Pros channel. In this video we're going to be going over some hard ACT math problems. I encourage you to pause the video and try some of these questions on your own first, as they're the hardest problems on this ACT math section. For every cent increase in price of a pound of apples, the grocery store sells 25 fewer pounds per day. The grocery store normally sells 800 pounds of apples per day at $1.09 per pound. Which of the following expressions represents the number of pounds of apples sold per day if the cost is increased by 3x cents per pound of apples? First, we're going to start off with the number of pounds of apples that they sell per day at this price, which is 800. We know that the grocery store sells fewer apples based on how much the prices increase. So we're going to subtract something from this 800. Next, we're going to see that they sell 25 fewer pounds of apples for every cent increase. So we're going to multiply 25 by the number of cents that's increased in the price, which is 3x. And if we simplify this expression, we will get 800 minus 25 times 3 is 75x. And this will represent the new number of pounds that the grocery store sells if they decide to increase the price by 3x. And that would be K. (57) Jason has been hired to build a circular wading pool in his neighbor's backyard. The rectangular backyard measures 60 feet wide by 50 feet long. Jason's neighbors want the pool to be as large as possible, with the edges of the pool at least 8 feet from the edge of the backyard all around. How long should the radius of the pool be in feet? So we know that the backyard has a rectangular shape to it. Since the neighbors don't want the edge of the pool to be within 8 feet of the edge of the backyard, we're going to use the shorter side to measure our length. So I'll draw a sketch of what the backyard might look like. Since the 50 feet is the shorter length, we have to have that within 8 feet of each side. So we know that this whole side here is 50 feet, and each end from the corner of the pool to the fence has to be 8 feet. So if we take the 50 feet and subtract 8 2 times, we're going to get 34. So that's going to be the entire diameter of the pool. It'll be 34. But the question isn't asking for the diameter of the pool, it's asking for the radius of the pool. So that means that we just have to divide this 34 by 2, which ends up being 17 feet long, which is B. 58. If f of x equals x squared plus 3, then f of x plus y equals what? We're going to plug in x plus y into the original equation wherever we see an x. So f of x plus y is going to equal, instead of x, we're going to plug in x plus y squared plus 3. X plus y squared is going to be x plus y times x plus y. And then we have plus 3 at the end. We can FOIL these two binomials to get x squared plus xy plus xy plus y squared plus 3. Last, we can combine the two terms in the middle to get x squared plus 2xy plus y squared plus 3, which is answer F. 59 says, in a game, 84 marbles numbered 0 through 83 are placed in a box. A player draws one marble at random from the box. Without replacing the first marble, the player draws a second marble at random. If both marbles drawn have the same tens digit, that is, both marbles are numbered between 0 and 9, or 10 and 19, or 20 and 29, etc., the player is a winner. If the first marble Dave draws is numbered 23, what is the probability that Dave will be a winner on the next draw? So since Dave drew 23, one of the numbers between 20 and 29, that means that there's 9 possibilities that he can draw a number that's a winner. That's 20, 21, 22, so on. Not excluding 23 and from 20 to 29. There's 9 different possibilities. Originally, the game starts off with 84 marbles, but since the player already picked one out, there's going to be 83 marbles left over, which gives us answer C. 60, which is the last one. What is the smallest possible value for the product of two real numbers that differ by 6? So we're going to do trial and error on this problem to figure out what the answer is. First, let's choose two very small numbers, or negative, very negative. We will choose negative 50 and negative 56. If we multiply these two together, we're going to get a very big positive number. So it can't be two negative numbers. Let's try two very positive numbers. We'll say 100 and 106. If we multiply 100 and 106, this is going to give us a very large number, somewhere around 10,000. But that's too high. We're looking for the smallest possible value for the product of these two numbers. Now let's choose the numbers closest to the middle, which would be 0. So 3 above 0 would be 3, 3 below 0 would be negative 3. If we were to multiply these two numbers together, we get negative 9. If we move each of these numbers one less, that would be 2 and negative 4. That gives us negative 8. If we move each of these numbers up one, that would be 4 and negative 2, which would also be negative 8. So it looks like 3 and negative 3 being negative 9 gives us the smallest possible value. If you learned something new in this video, make sure that you hit the like button, subscribe to the channel, and if you're looking for one-on-one tutoring, check out the link in the description. I'll see you in the next one.